Hi everyone. Today we'll discuss about valency, then variable valency. Valency means what? It is simply combining capacity. Here, valency is nothing but simply combining capacity of an element. Combining capacity of an element is nothing but valency of that particular element. How we can get this valency or combining capacity of an element? It depends on the particular atom. Different atoms will have different valencies, which depends on number of electrons present in outer shell. Otherwise, the number of electrons lost. Otherwise, number of electrons gained by that particular atom. Otherwise, number of electrons shared by that particular atom with another atom of an element is nothing but combining capacity. Otherwise, valency. So we have different definitions for valency. First one is here the number of electrons. The number of electrons lost or gained or shared with an atom of an element with an atom of an element during a chemical reaction. During a chemical reaction or chemical bond formation is nothing but valency. It is the number of electrons lost, otherwise gained or shared with an atom of element during a chemical reaction is called as its valency. In previous class, we have discussed about sodium valency. Sodium has to get a stable electron configuration. How many electrons it must lose? So here we can extend the number of electrons lost or gained or shared with an atom of element during a chemical reaction has to get a stable octet configuration. Stable octet configuration. Stable octet configuration is called valency. This is one of the definitions. What's the definition? The number of electrons lost or gained or shared with an atom of element during a chemical reaction has to get a stable octet configuration is called valency. Here, example I am taking sodium. Here its atomic number is 11. As to get a stable electron configuration, it must lose one electron during a chemical reaction. See, here last time we have discussed like this. When sodium loses one electron, it will get plus one charge. This is called as oxidation number also. Otherwise, its combining capacity is 1 now. Valence means it should not be positive, it should not be negative, it should not be even fractions. Valence is a simple number. Here you got how many electrons it lost? 1 electron. So that its valence is 1. If you take magnesium, here magnesium, its atomic number is 12. So as to get 10 electron configuration, otherwise octet configuration, otherwise nearest inert gas configuration, it must lose 2 electrons because 12 is the atomic number. So that 12 electrons are present. As to get 10 electron configuration, that is nothing but neon, which is inert gas, it must lose 2 electrons. So it is losing 2 electrons means here like this. How many electrons it lost here? 2 electrons. So that its valence is 2 and it forms Mg plus 2. Similarly, here I am taking one more example. Nitrogen I am taking. Its atomic number 7. For this also nearest inert gas is neon. Has to get 10 electrons. There is has to get 8 electrons in valency shell. Otherwise, octet configuration. It must gain 3 electrons and produces N minus 3, which is nothing but nitride ion. Which is nothing but nitride ion. So what is the valency of nitrogen here? 3. Should not say minus 3. Minus 3 is nothing but oxidation number or oxidation state. Here we are discussing about just combining capacity. What is the combining capacity of nitrogen here? It accepts or it gains 3 electrons, so that it is 3. If it is chlorine, I am taking chlorine here. Chlorine atomic number 17. Its nearest inner gas is argon. Atomic number of argon is 18. That means in that 18 electrons are present. If we count outer shell electrons, it will be 8 only. That means octet configuration only. But here total number of electrons are 17. If it gains one electron, it will get Cl minus ion. It is chloride ion. It is a chloride ion. So here its valency or combining capacity is 1, because it is accepting or it is gaining how many? 1 electron. So during a chemical reaction, how many electrons are lost, or how many electrons are gained, or how many electrons are shared with an atom is nothing but its valency. This is one of the definitions. Here combining capacity here is 1. For this magnesium 2. Combining capacity here is 3. Combining capacity for chlorine is 1. This is as per first definition. We have some more definitions. Here one more definition I am writing here. Valency is nothing but here valency is nothing but combining capacity only, but here number of hydrogen atoms. Number of hydrogen atoms or number of chlorine atoms. Here hydrogen is taken as reference. Here I am taking chlorine as reference. Number of chlorine atoms or twice the number of oxygen atoms. Twice the number of oxygen. Twice the number of oxygen atoms with which an element with which an element combines is called combining capacity, otherwise valency. Its valency. What's the valency? Number of hydrogen atoms or number of chlorine atoms or the twice the number of oxygen atoms with which an element combines is called its valency. Here three reference elements we have. One is hydrogen. How many hydrogens are present along with an element is nothing but valency of that particular element. And here how many chlorine atoms are present along with an element is nothing but valency of that particular element. Here twice the number of oxygen atoms. This is chlorine, then here oxygen. Twice the number of oxygen atoms means how many oxygens are present along with a particular element. Twice the oxygen atoms is nothing but valency of that particular element. See here I am giving some examples. Here I am taking NH3. NH3. Here reference element is hydrogen. So with respect to hydrogen, valency of nitrogen is 3. Why it is 3? Because nitrogen is combining with 3 hydrogens. Number of hydrogen atoms with which an element combines. So this nitrogen element combines with 3 hydrogen atoms, so that valency of nitrogen is 3. Okay? Valency of nitrogen. Valency of nitrogen with respect to W or T with respect to hydrogen is equal to 3. Similarly, here I am taking one more example, carbon tetrachloride. Here, carbon valency. Here, what is the valency of carbon here? As per the definition, valency of carbon with respect to chlorine, chlorine atom is how much? 4 chlorine atoms are bonded to carbon, so that it is equal to 4. For example, here I am taking one more example like NO2 and NO2, nitrogen dioxide. Here valency of nitrogen. Valency of nitrogen with respect to oxygen. Here valency of nitrogen with respect to oxygen is equal to how much? It is equal to twice the number of oxygens. Twice the number of oxygens means we can say here it is 4. It is equal to 4. Like this, we have different examples. I'll give some more examples here. For example, phosphorus pentoxide I am taking. Phosphorus pentoxide. In phosphorus pentoxide, number of oxygen atoms are 5. Number of oxygen atoms are 5. See here, I am writing compound P2O5. Here, reference element is, so with respect to oxygen, valency of phosphorus. Valency of phosphorus is equal to how much? It is equal to how much it is? See, 5 oxygens are there. 5 oxygens means twice the number of oxygen atoms. So 5 oxygens are nothing but 10 valency. Because twice the number of oxygen atoms, but here the 10 is the valency for 2 phosphorus. So while saying valency, we have to consider always one atom. For 2 phosphorus, 10 is the valency. But here valency of 1 phosphorus is equal to how much? It is 5. Why? Because for 2 phosphorus it is 10. One more example I am taking, SO3, sulfur trioxide. So here valency of sulfur with respect to oxygen is how much? 3 oxygens are there. But valency is nothing but twice the number of oxygen atoms. Twice the number of oxygen atoms is nothing but here 6. Valency of sulfur here is 6. Similarly here I am taking one more example. CH4, carbon valency I need here. No, along with carbon which element is present? Hydrogen. So as per the definition, number of hydrogen atoms. How many hydrogen atoms are present along with carbon? That is the valency of carbon. So here it is valency of carbon. Reference element is hydrogen. With respect to hydrogen is how much? 4. Because 4 hydrogens are present. In carbon dioxide, valency of carbon is again 4 because 2 oxygens are present. Twice the number of oxygen atoms are nothing but 4 in carbon dioxide I am telling. Similarly, we have different compounds. Here I am taking S2Cl2. So valency of sulfur I need now. Valency of sulfur with respect to chlorine. With respect to chlorine is equal to 2 sulfurs are there, then 2 chlorines are there. For 2 sulfurs, 2 is the valency. Because number of chlorine atoms. Number of chlorine atoms are 2, but this 2 is the valency for 2 sulfurs. So for 1 sulfur, it is 1. Like this, you can find valency of different elements. So two definitions I given. One is simple definition is combining capacity. One more definition is with respect to loss of electrons or gain of electrons or sharing of electrons during a chemical reaction. One more definition here is it is number of hydrogens, otherwise number of chlorine atoms or twice the number of oxygen atoms with which an atom of element combines is nothing but its valency. Here just observe the examples. Observe these examples. N2O3 if you take. N2O3. Oxygen is the reference. What is the valency of nitrogen? You can find. See here for 2 nitrogens, 3 oxygens are there. That means for 2 nitrogens, 6 is the valency. For 1 nitrogen, how much? It is 3. For 1 nitrogen, it is 3. For 2 nitrogens, valency is 6 because twice the number of oxygens. For 1 nitrogen, how much it is? Exactly half no? So here 1 into 6 by 2, it is 3. Like that you have to do calculations. It is very simple. Please understand this valency because further chapters in first year This valency may be considered as the oxidation number sometimes. But oxidation number and valency, the difference is valency is simple number. There is no negative, there is no positiveness, there is no negativeness. It is not zero. It will not be zero. It is not fraction. But the oxidation number or oxidation state may be positive, may be negative. Or sometimes it is zero. Sometimes it may be fraction also, 1 by 3 or 3 by 2. Like that, we may get different oxidation states. But this valence is always a simple number. No negativeness, no positiveness. Never be zero. Never be fraction. So that you have to remember. This is about simple valency. And next, one more term, that is variable valency. Now we'll discuss about variable valency. Variable valency is nothing but showing more than one combining capacity. Showing more than one combining capacity or valency is nothing but variable valency. Here I am writing variable valency. Variable valency is nothing but showing, otherwise exhibiting more than one valency. More than one valency. Otherwise, more than one combining capacity with the different elements in different compounds is nothing but simply variable valency. Now, we'll discuss about variable valency in metals. Variable valency in metals. About metals we have discussed in last class. What is metal? How we can decide it is metal? Metallic property, otherwise electropositivity, otherwise the compound, other the element which has capacity to lose electrons is nothing but metallic nature or electropositive nature, so that after losing electrons they'll get positiveness or positive charge. So for metals, here variable valency in metals I am writing. Variable valency in particularly metals. Any metal you can take. If it exhibits more than one valency, we can say it is showing, it is said to have variable valency, or it is said to be showing variable valency. Here same thing, exhibiting more than one valency. Here important thing is here examples. See here FeCl2 I'm taking. With respect to chlorine, valency of iron here. It is iron chloride. Valency of iron is equal to 2 because 2 chlorides are present. Similarly, we have one more compound FeCl3. Here, what is the valency of iron? Here, valency of iron is 3. Same thing, iron only, showing 2 valencies. In one compound, 2. In other compound, it is 3. So here valency of for iron is 2, here valency of iron is 3. Generally here one thing we have to remember, in any compound like this, in metallic compounds, always in that particular metallic compound in which it is showing lower valency in comparison. For that lower valency we have to pronounce it as as compound. Here we have two terms, one is as, other one is ik. This is ferrous chloride. This is ferric chloride. So in comparison, for the similar same metal in different compounds, if it shows different valencies, among those lower valency is considered as as, higher valency is considered as ik. So is ik and as, these two terms you have to remember. The compound here I am writing. The compound in which the compound in which a metal A metal shows higher valency. Higher valency. The compound in which a metal shows higher valency is indicated. It is indicated by the suffix. Suffix means after that word we have to write suffix indicated by the suffix. That is ik. Remember suffix ik. Ik ion we can say, or ik compound, ik chloride if it is chloride, ik sulfate if it is sulfate. It is ik, we have to use ik suffix for which one? Higher oxygen number. Similarly, the compound in which a metal shows lesser valency or less valency is indicated by the suffix as. So these you have to remember. See, because of this reason, here what we can write for this compound? We can write as iron only, no? For iron we have ferrum term. So here we can write here ferrous. This is ferrous chloride. Ferrous chloride. This as. Why I have taken as there? Because among these two, same metal, no? In these two compounds, same metal is present. But in this compound, metal is showing +2 oxygen number, otherwise +2 other 2 valency. In this compound, it's showing 3 valency. Means among these two, which is higher? For that we have to write ik. It is ferric chloride. Ferric chloride, and that is ferrous chloride. Like this, we have different compounds, different examples. See here, I am taking one more example. That is CuCl2, then Cu2Cl2. See here, with respect to chlorine, valency of copper is 2. Here I am writing V. V means valency. Valency of this copper is 2. Here valency of this copper is, for 2 coppers, 2 chlorines. Means for 2 coppers, 2 is the valency. For 1 copper it is 1. So among these two, which is having lower valency or smaller valency? Here. So this is called as cuprous. This is called as cupric. So we can say this is the cupric chloride. This is cupric chloride, and this is cuprous chloride. Here ik, here us. Just observe where I am writing us term, where I am writing ik term. In that combining capacity we have to remember. See one more example I am writing here. SnCl2 I am taking. Here SnCl4 I am taking. Stannum it is. So what is the valency of stannum there? Here V equal to, V means valency 2, because the 2 chlorines are attached to stannum. So that we can say this is stannous chloride. Here V equal to 4. V equal to 4. This is stannic chloride. Ik here us. When you have to use ik, when you have to use us, that you should know. Some more compounds I am giving here. Otherwise their valencies I am writing. Here I am not writing compound. Just I am writing Roman letter of their valency in Roman letters I am writing. Au 1 means its valency is 1. Au 3. So this is gold, but we can say RS, AuROS, RS ion. This is auric. auric ion. Similarly, here one more example, Hg plus 2, Hg, otherwise Hg2 I am writing, then Hg1, Hg2 is mercurous, mercuric ion. Among these two you have to compare. Which is higher, that will take ic term. Which is having lower valency, that will take as. It is mercurous, mercury. Similarly, silver also, Ag1, silver, Ag1, then Ag2. Roman letters in brackets, what I am writing is nothing but their valency. In mercuric, this silver one, Latin name argentum it is. So we can write argentus as here two argentic, argentus then argentic. Similarly, gold, silver, written. Many elements we can write, many ions we can write. For the same element, same metal, if two valences you are observing in different compounds. For that particular metal, in lower valency, we have to pronounce it as as ion. In their higher valency, we can pronounce it as ic ion. So this is about valency, variable valency in metals. It's about variable valency in metals. Similarly, variable valency in non-metals also we have, but for that different ions we have. For that we need some more concept with respect to electron configuration only. We can write how we can get different valencies or variable valencies for non-metals. In next sessions, we'll discuss about variable valency in non-metals. Up to that, just you remember this. For what is valency, then what are the different definitions of valency, then what is variable valency definition, then what is the variable valency in metals. If one metal is showing two different valencies, among those one should be lower, other should be higher. For that particular metal, in lower oxidation state, how we can pronounce it in higher valency, how we can pronounce. Generally, lower valency as, higher valency ic. Those terms we have to add as suffixes just with that metal atom. So up to this, remember, in next session we'll discuss about variable valency with respect to non-metals and further things. So stay home, stay safe. Thank you.